Welcome back, and we're going to be talking about 1.2, describing distributions, and do a little problem to check our understanding. If you want to try this before I explain it, that would be great, and then you can go through the answers or fast forward or whatever you've got to do, but I will do a detailed explanation of these problems. So without further ado, let's get this party started. Whoop, whoop. All right, so here we go. Um, First off, we have a dot plot. All right, this is one way to display some data. This is going to be some quantitative data right here. And our quantitative variable is quiz scores. Now we have 21 statistics students, all right, that score a 20-point quiz. So the highest mark you can get is 20. All right, what percent of students scored higher than 16 points? So what percent scored higher than 16 points? So we're looking for percent. Where this quiz score is going to be higher than 16 points. So we're going to have our x being the quiz score. And we're looking for what is the percent where it's going to be greater than 16 points. Okay, 16 points. And so really looking for the probability is actually the probability statement of what we're looking for. So right here, we need to count out of these 21 students. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 out of the 21 students, all right, scored higher than 16 points. And so what is that as a percent? And so we take 17 divided by 21, and if you can do that on your calculators, and you get about 81% or approximately 80.9, but I'm just going to go to 81%. And so that's approximately 81%. Okay, so 81% got a score of 16 or higher out of 20. Now let's describe the shape of this distribution. Now, if you look at the shape of the distribution, to describe this, the distribution, we're going to say the distribution of quiz scores appears to be, and it appears to be skewed. Definitely skewed to the left. All right, appears to be skewed to the left. And we have that right there. Okay, because you see that all the values are to the right, although major values are larger, and we have some potential outliers or lesser values to the left. And so do we have any outliers? Well, possibly. I'm seeing this one as a potential outlier. These other ones maybe could be outliers as well, but I'm going to say for sure that one, I'm pretty sure. So we're going to say potentially, I'm going to say this, potentially one outlier at 11. Why? Because it is the farthest, I mean, I'll say that is the smallest of all the values. All right, it is the farthest from most values. Okay, and there we have there. All right, farthest from most values. We got that. All right, and we can see that it is farther than from all the values. These are also farther, but they potentially maybe are not as outlierish as all the other values. Okay, so without further ado, let's continue on. So that's talking about the quiz. Now let's have another problem. And in this problem, we have here is a back-to-back stem plot. So here's what's known as a stem plot of 19 minuscule students resting pulse rates and their pulse rate after 5 minutes of running. We're going to write a few sentences comparing the distributions of resting and after exercise. So we're going to compare these two things. Now, when we're doing this, we first want to get the context. So we're going to compare the socks. Okay. So we need to have the shape. We're going to have outliers, center, and spread or variability of this data. So in looking at this, And looking at this, we can figure out the shape. Now, is there any difference in the shape? So the shape of the resting and after exercise heart rates appear to be both, I think they're both skewed to the right, because we're starting here, and you can see, looking at our little key right here, this is 86, and then it goes to 146, and down here it starts at 68, and it goes all the way down to 120. So it definitely has some values which are starting small and getting larger. So that's going to the right. So both appear to be skewed right. Okay, both skewed right. The next thing is, do we have any outliers? Okay, any outliers? I don't see any strong outliers. We maybe could say this one at 120 could have a potential outlier, and 146 could be a potential outlier. So we could say the distributions. Now, because we already said the shape of the resting and after exercise heart rate distribution, maybe I'll put that in there. Distributions appear to be both skewed to the right. The distributions both appear to have one outlier, and we will write that at 120 for resting and 146 for after exercise. After exercise, and so we got that. The distribution, if we look at centers and we take this median, so we have 19. So we're looking at, when you look at medians, and since they're both skewed, I'm looking at the medians. And that's one thing you do want to know. Whenever you have skewed data, always look at the median values, and the median is the middle value here. So 19, so we're looking at, we have at number 9, all right, 9, 10. So we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously, the after exercise appears to have a higher median than the resting heart rate. So the distribution the median, I apologize. The median after exercise is greater. Notice I'm using comparative language, is greater than the resting median heart rate. And that's all we have to do. If you want to tell what the actual value is, we can put that actual value down as well. All right. That's what we have there. What is the other things we know? And we're talking about spread. And if we look at the spread, we can see that the spread here is we're starting at 68. All right, so 68, and we look at the range. So 68, and we have all the way up to 120. And so there is a spread of, so there's a range of 52. All right, beats. So this resting has a range of 52. All right, and here we're going to have 86 is our minimum there, and we're going to 146. This one's 60. All right, and we found this range just so we know. I took 120 minus 68 to get that range. Okay, and for this one, to find the range of after exercise, I took 146. Always check my work. Don't take my word for it. Hopefully I did it right. And our range is 60. And so finally, we can also say right here is that the range after exercise is greater than, and I'll write that a little better, then the range um, of the resting distribution. All right. And that is what we can say. And so those are the 4 criteria. Notice how I use context in each. The shape of the resting and after exercise heart rate distribution appears to be both skewed to the right. So both of them are skewed to the right. Distribution both appear to have one outlier, 120 resting and 140 for after exercise. The median after exercise is greater than the resting median heart rate. And then the range after exercise is greater than the range of the resting distribution. All right, so we can see that this right here, I was able to compare the distributions of the resting and after exercise pulse rates. And up here, I was also able to use that dot plot to figure out the shape, potential outliers, and also figure out some percentages and proportions. Okay, so I hope this helps you out on describing distributions, and we're going to go through another example in just a little bit. All right, good luck and God bless.